Thank you so much for joining me this morning. Welcome to Designing Healthy Environments. I am Alicia Ponce, founder and principal of AP Monarch. We are architects and sustainability consultants. And this morning, I am here with Craig Burton, engineer with Interface Engineering. A little bit about Craig. So we met, I think, 5 years ago, is it? I was trying to think when that was while we were on a project together. And a little bit about Craig. He focuses on the evaluation and integration of emerging clean technologies into projects. He has dedicated his career to this purpose and has worked across a broad range of scales and building typologies, including the role of MEP engineer, energy modeling, daylight, and building sciences analyst. As a collaborative engineer, his work has been informative in shaping architectural designs, campus communities, and in realizing high-performance buildings around the world. So thank you so much for joining me. There's so much to cover, but today we're going to talk about Passivhaus commercial projects, which you are very familiar with. So welcome.
Yeah, no,
How have
thank
you been?
um, Great, doing great.
Yeah, so um, like I said, we're going to talk about Passivhaus commercial, which I'm very curious. Mostly what my experience has been is with residential and Passivhaus and reading, familiarity with projects and so forth. And so I'm very curious about the commercial aspect. So just to talk a little bit about, before we get into that, can you explain what Passivhaus is?
Yeah, for sure. So Passive House is kind of a concept, really driving around making energy consumption of buildings maximize their passive potential, utilizing naturally occurring elements, predominantly the sun, and shape
Okay.
forming buildings such that they reduce the reliance on active fossil fuel and or renewable based heating and cooling systems. The passive house movement originated in Europe, 1980s, I think, is sort of where the modern version of it has derived from. But you can go back to many centuries ago, where vernacular architecture is mostly informed by passive principles, whether it's shading, appropriate placement of windows, and the like. The current incarnation of passive house buildings in the United States and North America are really driven by sort of a renaissance kind of application of the passive house movement from Germany within the US. And that occurred through the 2000s and early 2010s. And predominantly, and as you mentioned, has focused on single-family homes, and perfecting home builders' construction methods. The systems that we use to build residences, whether it's windows, insulation barriers, or structural framing solutions.
Mm-hmm.
Always in the background, there's been this idea that we can apply passive house principles on whether it's envelope or HVAC systems to commercial buildings. And
Mm-hmm.
of course has actually happened in the background without the same volume sort of throughput as the single family home market. But there are many multifamily buildings that are built to passive house standards and certified. There are numerous commercial office buildings that have been built. And then on the institutional side, whether it's schools or community centers, there's many projects that have been built around the world. So that's really kind of the scale of focus that I've been working at. But I have had the fortune of working and designing passive house single family homes, multifamily buildings, as well as institutional, a youth campus in Wyoming.
Mm-hmm. No, that's great. And the principles that you're talking about, so I'm familiar when I read about passive house, I instantly think about residential, but I know like around the past 5 years, at least in my experience, there's been a push for commercial. We can design this way for larger projects. At least, we're in Chicago, and that's the conversations that I've been involved in. So the five principles, do they apply? How do they translate from residential to commercial? Because obviously we're talking much larger volume.
Yeah. So it's a good question. I think the principles translate. Perhaps the technical details that are solved extensively in single-family home market look very different for a commercial project. In a single-family home, you've got most likely punched windows that you're going to a myriad of different window vendors that sell wood framed or vinyl thermally broken windows. When you get into the commercial space, that solution is not typically the starting point. You're looking at either a curtain wall or stick frame window construction, and those vendors and systems are detailed differently. There's different systems or details you have to solve for, and I'd say that the vendor community to support architects in that world is perhaps a little more limited than in the residential sector, where there's just more volume and more throughput. But I think to your point, the principles of Passivhaus basically are taken from the single family market and applied to the commercial and multifamily market. It's just that the way that we solve for it and the way that we look at kind of the math problem, we're trying to balance between positive solar radiation and excess solar radiation, heat gain and heat loss, and then ventilation balance in and out. It's a different math equation when you're looking at a 15-story office building than with a single family home with 3 bedrooms and a kitchen. So typically we end up looking at more centralized systems that perhaps have additional controls or ways that they're configured that allow those same sort of technical parameters at a single family level to be achieved, but following the same principles.
Have we mentioned the 5 principles? Just it's.
I'll probably miss one.
I have them written down.
Oh,
I can just in case I forget too. Well, it's the one is continuous insulation, right? You want to minimize that thermal bridge. You want to eliminate it, right? As much as you can, right?
Bridges
you want an airtight building enclosure. Optimize window performance and solar gain. So orientation is huge, from the get-go, at least from new construction, right? And then we're talking about like active MEP system strategies, like balanced heat, moisture, recovery ventilation. And 5th, you want an efficient, minimally sized active system.
Yeah.
Right.
So let me go through those real quick.
Yes.
I'll speak to have more expertise in. So thermal bridging is a really important detail, and I think one if you're working on a commercial project, a good question to have in the SD or DD phase, before you're into CDs, is working with your structural engineer, looking at how different elements of the building are supported. And I'm talking mostly about the exterior envelope, because they will propose systems, whether it's shelf angles or offsets, that they've used on prior projects, and those systems are probably right solved or right sized for the driver of the project, which if they've only worked on developer projects before, it's probably solved for what's the easiest and less complicated a system to install. And what we need to make sure that we're designing towards is a system that inherently doesn't have faults that are impossible to solve once you've already kind of locked in on a curtain wall or an overall enclosure system. So I think if you're working on a passive house project, or you have a client that's interested in potentially certifying, or maybe just taking the best practices from passive house certification,
Mm-hmm.
asking your consultant to bring forward those details that provide for thermal braking, that provide technical solutions, material or a specification that minimizes cold bridging between the exterior and interior, such that you're putting in a good quality envelope and has the potential for realizing some of these benefits. So the role that thermal bridging has in passive house buildings is much more pronounced than in regular construction, buildings built to code,
Mm-hmm.
because we're investing so much more additional money and performance in the envelope pieces that you can see, whether it's exterior wall insulation or the window openings. So those little pieces, whether it's a connector, a drill, a screw connection, or a shelf angle offset, those little pieces that kind of make up, less than 1% of the gross envelope area, they'll end up being 20, 30 times more conductive than
Mm-hmm.
other opaque and transparent elements. So
Mm.
that becomes 30%, and an effective overall U factor calculation for the envelope.
So it's definite. I mean, again, with high performance design, it's a collaborative effort, right, from the beginning.
It certainly is, and the potential the challenge is that you spend all this money on these high performance windows, this elaborate envelope detail, and then you leave these connection details to the wayside, and they really mitigate all of the investment that you've made in the other elements. So it's an attention to detail that you start early on in the process,
Hmm.
such that when you get to the end, there's no surprises.
Right. And I mean, and then the end goal, you want it to perform well, right? And you want it to have really good air quality and comfortable, right? The
Yeah.
comfort is key.
So the other thing that's, I guess, useful or useful to know about passive house projects is that we may have the perception that passive house is just about, using a very small amount of energy to heat and cool a space, and that
Hmm.
people must be wearing sweaters inside the whole time. There's no boiler or chiller; it's just all passively heated and cooled, and that's not really the
Everyone plugs in their personal heater, right?
case. That would be a disaster. So the way that the Passive House certification and really design guidelines work is that the emphasis around the specification of the envelope is not purely looking at how many kilowatt hours of energy the resulting building consumes. It drives the performance specification for all those elements towards a level that ensures the building is comfortable, that windows don't provide excessive radiant imbalance between the window surface and the interior surfaces, so that you feel cold when you're next to a window. At the same time, that the infiltration level associated with the overall enclosure is tight enough to minimize or basically stop appreciable drafts occurring around penetrations in the envelope.
And are you referring to most new construction? Because that's what I'm thinking. Is this applicable to a renovation project, or maybe an addition at most, or what is this applying to?
The system can be applied to any scale or type of construction. I think what you'll find is that with new construction, when you have carte blanche, you have a site and perhaps you have fewer constraints than with an existing building. You have, I guess, more options to solve for the energy balance. Excuse me. So with project. It's not that it's impossible. There's a single family home in Chicago that was presented at the Passivhaus conference this year in Washington, D.C.
Mm-hmm.
Recently gone through, and I think it's still in construction maybe.
Mm-hmm.
Passivhaus as a certification means for the renovation. There's several projects in the Chicago area that have included additions, I believe. All single family sort of home construction. But I would imagine from project economics, you'll have potentially a cleaner path to the end solution if you're starting with new construction.
Mm-hmm.
That existing building can't be reskinned, retuned.
Mm-hmm.
Um,
What is it that clients ask for? Why do clients ask for Passive House certification rather than other green building certifications? What is it about Passive House, that clients lean to?
yeah, good question. My understanding from what I've seen and from what I've heard and the clients that we're working with is that clients appreciate the focus on the quality of construction and the technical detailing associated with a Passive House project. It's not just a plaque on the wall, on the door, walk into a building, and that's not doing any other sustainability certifications
Mm-hmm.
exist. It's just that those other voluntary certification schemes have different paths to achieve levels of certification, and you don't really have a consistent knowledge of how the building's built. It's been built with a myriad of different strategies. So a Passive House building has very rigorous requirements for how the building is designed and constructed. There's specific limits on the amount of the load for heating and cooling that the building can be designed for. So just by it being a Passive House building that the mechanical system has been right-sized very aggressively in tandem with the investment in the envelope and infiltration. And owners recognize that the mechanical budget, the cost for the heating system is correspondingly reduced. The system is smaller because we're investing so much money in the envelope and the enclosure package to build, what we would traditionally rely on, a fan coil and a boiler and a chiller to provide, comfort solutions to our occupants. So that doesn't really help anyone when we're talking about climate change. Then we're talking about energy efficient buildings. So Passive House kind of provides the rigorous documentation and requirements for that project to really deliver on a project's overall energy efficiency potential.
So you see the long-term benefits. I mean, as the design team is working on the design, right? You as an engineer and energy modeler, you're working closely with the architect to look at the energy performance, right?
Yes,
as a long-term benefit.
for sure. So the energy consumption, of a Passive House project, and we'll talk about commercial scale projects. I'm working on one now.
How large is that project? Are you allowed?
50,000 square feet. It's mixed use, commercial, residential, the EUI, so the energy usage intensity of the project, is around 12 kBtu per square foot. So that's some jargon for the non-technical folks.
I mean, so compared to a non-Passive House, what does that mean? Like, what is a non-Passive House EUI?
So the code compliance, so building this.
Okay, we'll go by code.
Code requirements for this project, which is in Seattle, would be a kBtu of about 60 per year. So this is a sixth of the energy consumption used on site. For typical net zero energy buildings that are designed to be very efficient, but working within really the amount of solar you can put on the roof to offset the energy requirements. Typically, the EUI of those projects are around 20 kBTU per square foot per year. So Passivhaus kind of takes it, one step further and beyond what normally, when we look at sort of investment and performance, beyond where we see diminishing returns in investing in the next R factor or U factor for Windows. So that's kind of the economics of a passive project. The other part that we hear developers appreciating is the detailing during construction, the minimizing of infiltration, because infiltration is indicative of a problem or failure with your enclosure system and will result in, especially in a commercial project, failure, mold, or water ingress at some point, which the owner then so the passive construction through the on-site monitoring during construction, which is a key part of the certification, really ensures the owner is getting the highest quality product that they can, I think, with the least amount of work from their side, specify.
Mm-hmm. And with the EUI, I just want to talk a little bit about that. And it just really, it means it's less reliability on mechanical systems, right? Because like you said earlier, you're right sizing the mechanical system for that building. So you don't have this large piece of equipment that's working and, you look down the chain, it's emitting carbon, right, into the atmosphere.
Yeah.
Right?
Yeah, so you still have a mechanical system in Passivhaus project, especially a commercial project where you most likely have multiple zones in the building, which require different levels of heating and cooling, and you have distributed people everywhere. When I was talking earlier, typically these projects end up with some type of centralized ventilation system, and there's different models for that. But those ventilation systems, they require fan energy to move air into a space and then back to the air handling unit. What's different with the Passivhaus project is that almost exclusively that air handling equipment takes the shape of what we call an energy recovery ventilator. And its job is to provide fresh air, remove stale air, and then exchange both sensible temperature and then humidity latent temperature with those return and supply streams to really recoup all of the energy we've spent within the building, heating and cooling that ventilation air. And then the ventilation air it follows what we call a balanced air approach, where we're really providing just a tad more ventilation on the supply to pressurize the building. But that's not so much of an issue with Passivhaus projects because the infiltration levels are so low. We're not trying to overcome too much in the way of air pressure on the building envelope because our envelope's so tight. And that's a way to recoup some savings on the mechanical system through the attention to detailing in the envelope.
Yeah, and to me that you're talking about comfort, the occupant comfort too, that attention to detail for, fresh air. And it's all, as an occupant, you're looking at comfort. As an engineer, you're looking at the performance. As the owner, you're looking at, the operations and maintenance, so, long-term benefits. Why do you think, well, let me just say this. Does a Passivhaus project perform better than other green building certifications? And you and I have both worked on, all the other green building certifications. And so each one, addresses a certain issue, right? Where I think Passivhaus is looking at the energy performance, indoor air quality, and comfort. And it kind of would be a nice complement to the WELL certification, right? Where you take it a step further and really focus on the occupant, right? What do you think about performance compared to other green building certifications? And then I have a follow-up question.
Okay. I'm personally a huge fan of Passivhaus because of its focus on the overall efficiency of building, and to how we're using energy, and really they kind of follow a budgeting process. Looked at this a few different ways over the years, and that's really the evolution of the certification system. But they basically look at what is the minimum amount of energy that we need to put in this building to sustain comfort without relying on fossil fuels. And there is a point, and there's several larger statistical studies that they did with the national labs to generate these kind of budget points. But there is a point after which it doesn't really make sense to make the wall thicker, or it doesn't really make sense to make the energy recovery ventilator that much more efficient. So they've kind of defined those points that are economically viable based on the cost that they went through, and what that means is that following a certification project, you're basically ensuring that you're putting in the most, so the least cost on an annual basis, HVAC or electrical system that you could for that program type and that project, because the envelope has been balanced to provide as much useful heating and cooling and stop as much excessive heating and cooling that it really could with technology that we have today and the manufacturers that manufacture products. So I personally love it because when energy efficiency, you put in a building.
Says the engineer.
You build a building, you say, this is what it's going to look like, and here's our budget for MEP. Then, okay, we can select energy efficient systems within that MEP budget. It doesn't necessarily represent the absolute lowest amount of energy that the building could use, because we haven't to basically balance the construction budget from MEP and envelope and really drive the potential of the envelope in determining the performance of the building. So about a passive house project, especially for multifamily commercial, that optimization must have occurred to reach those requirements. And as such, utility bills for the building, they're minuscule. But passive houses added in their last iteration, the Passivhaus 2018, I guess they had a version of it before for 2015, is the potential for a net zero certification. And they go about sort of calculating that in a way that is a little bit different than like the Living Future program, or even the Department of Energy or NREL's definitions for net zero. So I think I don't know. I've got my opinions about that too, but I think
we all do.
The certification for energy efficiency, I think, really stands the test of time because it inherently addresses energy efficiency, comfort, and quality of construction. And you don't necessarily get that with any other certification scheme.
Yeah, I remember, I think it was almost 15 years ago, and I was a part of the education committee with the USGBC, the Chicago chapter, now Illinois Green. And we did a study of the first round of LEED certified buildings. And the whole intention with green buildings was to, because of climate change, right? And how do you build better? How do you design healthier? And that first study, I remember it was just like this big aha moment, or, of course, although the buildings were more intentional, like on recyclability, materials, and having the occupant walk to the site or to the workplace and stuff like that. The study found that the buildings weren't performing well; they were just awful, right? And so it was a great study. And so then you saw the new versions of LEED really, focus on the energy performance. And then it just went on a whole nother level, much more meaningful level, that okay, now we mean business and how we're gonna design these buildings. And so it really I that's why I just love being in this part of the field, green building, is because it's innovation, right? It's iteration after iteration. So, and then, your profession, I just look to you, right? Okay, so what does the energy model say? What is it saying now, and you help inform the way, that design starts looking. Um, so yeah, I remember that study, and I never forgot that, just what the results revealed, what the study revealed. Hmm. And that my follow-up question. What about like water conservation, in passive house, and the focus on carbon reduction? Because as architects, that's what, our combined mission, or as building professionals, our combined mission is to reduce carbon, right? To bring carbon down, because as we know, buildings contribute to 40% of those carbon emissions in the environment.
Yeah. So as part of like the key components of Passive House certification, there is not necessarily a water efficient requirement above and beyond what is required through water regulations. There is a focus on water as it pertains to hot water, and
Okay.
that insulation is specified appropriately, and that recirculation systems are used where they can help reduce water consumption. A lot of the wastage in water in single family or multifamily is to do with the distance between the last leg of the domestic hot water system, which is kind of a detail that most developers don't necessarily think about, but is a key part of that section of a commercial passive house project. And it's just ensuring that when you turn the fixture on, you're not waiting for 30 seconds for hot water
Mm-hmm.
to show up, because that's all water that just goes straight to the drain, and is wasted. So I think that's one thing to your questions earlier about other certification schemes. Passive House doesn't necessarily look at materials, doesn't look at the overall site,
Mm-hmm.
biodiversity, doesn't look at anything that we would visually point at and say, this is a sustainable building. Passive
Mm-hmm.
really looking at, okay, here's the form and the function of the building. How can it be best organized to be the most efficient from an energy perspective that it can, and deliver against occupant comfort and durability in its lifespan. So I think what we typically have seen on, I guess, commercial projects that I've been involved in, is that we actually have 2 or 3 certification schemes that we're going.
Mm-hmm.
So the youth camp that I'm working on, that's a triple certified project. So
Mm.
LEED Platinum, Living Future Net Zero, Pedal, and then Passive House certification.
Wow. Congrats. When was that certified?
It's it's in
Oh, it's
construction.
in construction. Okay.
Um,
Okay. So we'll be following that project. That sounds like an amazing project.
yeah, and a client that appreciates and understands, the value of the different schemes. And I think Living Future and LEAD are more complementary, or sort of maybe,
Hmm.
whereas Passive House is more complementary to other schemes because it doesn't necessarily, overlap. It more informs a positive outcome for those other schemes. Um, and I think that's where I see its value is that it's more of a design tool guideline to teams to realize the highest level of efficiency,
Hmm.
quality, and then other aspects that are more holistic and around sustainability can be addressed there.
Hmm. Yeah, I think even though, Passive House has its focus on the envelope and energy performance and comfort, those projects, they inherit these design features anyway, on site, on, landscape design. I think that's, when you have a good team, um, you know what other features you can add on there. And they don't necessarily have to cost more. You just, because you have that knowledge, then you can definitely add that on there. So we've been working from home for 4 months. I wanted to ask you, how's it going, and like what's your prediction on where we're going?
Yeah, right. I don't have my crystal ball handy, but
Nobody really knows, but I love reading all of these articles. Like this is going to be the new normal. This is going to be, but
yeah,
nobody knows.
yeah. No, I don't try to take a higher road. I maybe try not to get too bogged down in microcosm sort of views of what the future impact is on any particular sub market, and
Hmm.
what will the overall trends or what I'm interested in. And I think um, sticking I guess with MEP. There will be, whether it's for new projects, for existing buildings, figuring out how to be repurposed, or existing buildings, figuring out how they can be retooled to serve that original purpose. There is a large interest in figuring out how mechanical, electrical, and plumbing systems can support a better uh, indoor environment, and one that I think more closely represents the things that we look for in the outdoor environment, in places where we feel comfortable, we feel safe, and we feel like we're spending our time wisely. So I think for commercial spaces, there can be a lot of attention to what ventilation systems are doing. Um,
Hmm.
Multiple clients on assessing how their existing air handling equipment can be adapted to realize, I guess, some more advanced control and sequencing operations. I think for new projects, there's going to be more of an emphasis on what type of system we're putting in, and potentially looking at ways to maybe even just give a kick in the pants to a trend that was already occurring,
Hmm.
but moving away, in a sense, from all air systems that rely on mixing volumes of spaces in commercial space,
Hmm.
and moving more towards decoupled systems where ventilation air is treated and delivered separately from heating and cooling in a space, which can be delivered through some type of other terminal device. And there's a lot of interest
Hmm.
into systems as a solution that does not involve mixing of air, and provides the highest level of comfort, energy efficiency, and indoor air quality. So that's actually the base system for two of those passive house projects that I'm working on now, is
Hmm.
radiant hydronics. there's been a lot of interest in that over the years as it pertains to energy efficiency, but without as much emphasis on how it works with an overall healthy building. So that's a trend that we see. I think an area that perhaps is not directly related to COVID, but I think will be something that's celebrated as a new generation of buildings, are mass timber buildings. And mass timber buildings that visually embrace and celebrate the natural material. It's a technology and a material type that addresses many concerns surrounding climate change, surrounding material sourcing and supply chains, and has, I think, the ability to really impact the market for new construction as it pertains to buildings that visually and also work with the performance side of things appear to provide more healthy, engaging spaces.
Oh, it's fascinating. I can't wait to see what comes next, because we're living in a world where everything that we knew and know merged under one roof, right? All at the same time, unexpectedly, and then we had to adapt quickly. I mean, we were working at home, or we have kids and they're learning at home, and we're cooking, we're cleaning, and we're doing everything, and meanwhile, we're talking about designing the new workplace, right? We still don't know when we're going to go back. I know some offices have like 10%, occupants, or 50%, but I think everybody's going to learn from that. And so I can't wait to see what's going to happen. But thank you, Craig, for joining. It's good to see you after several months.
Yeah, for sure.
Right.
I'm glad to share my perspective on Passivhaus. I think one thing I should have mentioned at the beginning, I'm not a Passivhaus Institute US. I don't on behalf. I'm just speaking from my experience. So hopefully I didn't misrepresent any of their programs or. But
we'll find.
They're located in Chicago. They're sort of corporate or headquarters. Katrine is the lady that runs the office. Lisa White is the individual who's, I think, mostly engaged in certification and the WUFI modeling, which is most of the design back and forth that happens on larger buildings. So great resources. Find if you haven't already, and ask your consultants about how this could pertain to your project, because it's an exciting and very applicable certification for projects that want to achieve measurable reductions and milestones towards addressing climate change.
Yeah, I mean, that's what this talk is about, designing healthy environments. We call ourselves the pollinators of the built environment. We want to be able to design healthy environments for you, for the earth, and for all. We have one comment here. It's Nati Quintanilla. Very interesting discussion, guys. Glad to hear your thoughts on Passivhaus. So, yeah, I thank you again. We'll be sharing this talk on LinkedIn, so others can join and comment. Next week we have Marty Brennan from DGF Architecture, and he'll be talking about light health, really focusing on light quality, circadian rhythms, and so forth. And then after that, we have Tom Bassett-Dilley. He will be talking about Passivhaus residential. So it just kind of worked out.
Yeah, I think Tom, from what I know, is a pretty good authority in the Illinois market. I think he's heavily involved in. There's a local Passivhaus chapter, which they have monthly meetups, and I've attended. Not an active participant, so.
Yeah, me as well.
Extracurricular activities, but
Yeah, so please join us for those talks, and I can't wait to talk to Marty and Tom. They're gonna talk about their, contributions of how they design healthy environments, and we'll see you next week. So take care, and hopefully we'll see you soon in person. Bye.